Hi everyone. Today I want to share with you a paper that can use one policy network to control all those morphologies. The title of the paper is One Policy to Control Them All, Shared Modular Policies for Agent-Agnostic Control. The idea behind this paper is deep and big, so that's why I share this paper with you. Let's first take an overview of this approach. So imagine that we need to come up with some policy network for all those morphologies, all those robots on the left. How can we do that? So what this paper proposed is that we use one shared policy for each body part. So this is a body part. By doing this, we have one policy neural network for all those robots. On the right, this is the architecture of this policy neural network. We can see there are message channels from one policy network to the next one. This is his parents, and this is his parents. And these are the morphology that are tested in this paper. Now let's look at the results of the experiment. The green line stands for both way message passing. So the message is passed both from parents to children and from children to parents. Those body parts has orientation. They can have parents and children. They're different. And the yellow line here means that we only enable the message passing from the children to the parents. And the blue line here, top down, means the message only pass from parents to children. And no message here means we disable all the message passing. So all the body parts react independently. The purple line, the baseline here, means that using one single traditional reinforcement learning for all those morphologies. So what if there is not enough actuators or sensors? They just pad zeros in the input vectors. So we can see here the both way message passing achieves the highest score in all those cases. We can see the similar results here, and those are the morphologies this plot is corresponding to. So what is amazing here is that they do not train the policy neural network on all the morphologies. They only use 80% of the morphologies and hold 20% as unseen test set. So the trained neural network also works well on the other 20% unseen variants, unseen morphologies. This result implies that there might be a general control policy for all the robots. So imagine that in the future we can train a general purpose policy controller and deploy that policy controller to all previous unseen robots. That's amazing. Okay, now we have basic ideas of this paper. So let's read it again more critically. So the title of this paper is One Policy to Control Them All, Shared Modular Policies for Agent-Agnostic Control. So here, the author used modules and agents. So there are several similar words and phrase in the paper, means basically the same thing. Modules, limbs, modular components, nodes, and they all means that this the body part. And the agent here means body. And in the paper, there are several similar terms like morphologies or environments. Environments is has the same meaning of had the same meaning as the agents. And we can discover the lineage of this paper. So if we want to know more about how this idea comes from, we can visit Professor Badak's website. And we can see the keywords here are self-supervised, self-assembly, uh, and curiosity-driven. So those are all related ideas. Now let's take a look at the video of this simulation. So we can see that they use Modular as their simulator. Modular is a widely used 3D physics engine in reinforcement learning field. And in the 3D simulation, if you don't give the object any forces in the y direction, you can constrain the object and all the movements in xz plane. What I discovered is that the gravity here seems smaller than the reality. So if we speed up a little bit, like 2 times speed, and we can observe that that's much more realistic now. And now let's look at the implementation of this paper. I should say that the code is very well organized, and it can even serve as a template for my future work, I think. This is the GitHub repo of this project, and these are requirements. And I should point out that I have CUDA 10.1, and I also successfully installed this project. So just go ahead and give it a try. Okay, now let's look at the modular communication. This is a figure 2. We can notice that the subscribes are all T, which means all messages are passing instantaneously to one another, which also means that if I'm the head, I can instantaneously feel what's happening on the foot. This is reasonable because our nerve system is basically a highway system of our body. So they just passing messages back and forth in a very high speed. But here we can also ask, what if the message passing takes time? What if this t becomes t minus 1 or t minus I? So what will happen here? And this is my question about the communication. Now let's look at a very important and interesting observation here. The emergence of centralization. I think this is the most exciting part of this paper. They observed that once we enable the both-way message passing, there will be some master node emerges from all the nodes, all the body parts. I think this is analogous to, say, if we bring a group of people together and during their interaction, some pattern must be emerged from that interaction. And maybe like one leader or two leaders will emerge from them. And imagine what if we can apply this idea of modular nets to like computer vision, for example. If we have a lot of identical modular neural network to deal with one picture, and we can ask the emergent um, centralized node that what's going on in that picture. And by doing so, it might be more robust than current methods. In the description, I'm going to share a paper comes from the biologist Professor Michael Levin, in which the observation I think is quite analogous to these methods. So if we search the term gap junction, we can see not only the nerve systems has connected nerve cells, but also in our body, all of the somatic cells are connected by gap junctions. It will be very interesting to see that this idea can be in the future can be applied to the entire artificial intelligence field. Okay, this is all I learned from this paper. I'm a master student at the University of Vermont, and this is my first time sharing my thoughts of a paper on YouTube. So if this video provides you any information that is interesting, please give me a thumbs up. Thank you very much.